welcome students for today's class. Today we are going to see this is the continuation class of the last class. Last class we have done the connection oriented transport TCP, where you are going to see the four things, and we have finished already the first 2 points, that was segment structure and the reliable data transfer. So now we are going to see the flow control and the connection management. So all these 4 points you need to write under your connection oriented transport, that is TCP. So now moving towards the next slide, you can see here one diagram. This is not known as your TCP flow control. You can get the different question directly, like how you are going to express about the TCP flow control. You need to, that can come for your 6 marks of question. So that time you need to do the diagrams, and along with that you need to write the explanations. So here you can see what is happening. This is nothing but this is a protocol stack. So in this protocol stack there will be some application process. This yellow mark is nothing but this is the socket, which is also known as your TCP socket. And you can see the receiver side, it will receive some of the buffers. Then you are going to write the TCP code and IP code. So how it is going to work, how it will take the packets from your sender side, and how it is going to work out. Here, whatever the blue color lines you can see, all these things are nothing but these all are your datagrams. I told you that in application layer we are calling it as your packets, but in the next layer we are calling, in your network layer we will call it as your datagrams. So here in the packets will be moving from your, you can see the red color mark. So the packets are moving from your sender side. It will go till up to your sockets, okay, that is inside your network layer, and it will give the delivery of all the datagram packets, and then with that it will come back to the with the acknowledgement to your sender side. So this is nothing but this is the way how the datagram packets or datagrams are moving from your sender side to your receiver side. And how it is going to get connected with your application process. What is the job of your application process? The application process, in this process it will just remove the data from the TCP socket buffers. Why it will do? Because whenever the sender will cross this layer and it will reach the network layer, it will deliver all the datagrams which will be written in your IP code. Everything it will deliver, and that things will be inside your receiver buffers. This blue color is nothing but this is known as your receiver buffers. Once the datagrams will be delivered here, then the application process will start working. It will remove the data from this TCP socket to generate the acknowledgement. Then the acknowledgement will generate, and this application will goes in this way to your sender side. So now the question arises like, what happens if the network layer delivers the data? If the network layer delivers the data faster than the application layer removes the data from socket buffer, what will happen? Suppose you have the network layer has been delivered the data is very fast, but the application layer is unable to remove the data. So that time what will happen, that also you need to see. You can see the diagram here. In this diagram, what is happening, there are some two pictures. So this picture, how we are going to relate to our TCP flow control. This is nothing but whenever we are seeing any kind of movies or any kind of small video, that time if there will be any buffers, it means that we are unable to catch out the data. Okay. So if there will be no buffers, it means that the network layer is sending all the packets or all the datagrams very fast. So that time what will happen is you won't get the buffers, because buffers will get clear from your application layer. But if you are getting buffer, it means that the application layer became slow, or it is unable to remove the data packets from your receiver buffer. I hope this question got clear. Now you can see here one more thing, how these things we are going to write in our segmentations. How this is our segment structure, TCP segment structure, how you are going to write. So here we have some of the data value bits of data where it will catch all the receive window, and also it will have the number of bytes receiving from your acceptance. Through your acceptance, what all are the data values it is getting, everything is going to store inside this receiver receive window. And one more thing also you can see here, the flow control. Now exactly what is the meaning of your flow control? It will receive the controls sender, receiver controls the sender, the receiver side it will control the sender, so that the sender will not overflow with all the packets. Because if it will overflow with all the packets, then there will be the chance of losing the packets, otherwise there is a chance of congestions. So what will happen, the receiver will have all the hold on the sender, that when it is going to send the packets. But suppose what will happen, the receiver will come to know that the sender is unable to send, then how the sender will come to know that the receiver is asking to wait. All these things will happen whenever the receiver will send the acknowledgement. That time the sender is going to wait to send the next datagram once it will receive the acknowledgement. Okay, so if it the transmission rate, if it will be so fast, we may lose our data packets, or we may have the congestions. So we need to avoid all these things. Who will help us to avoid? The receiver will help us to avoid such kind of situations. Now moving towards one more slide, here you can see the detailed description about the buffering part, how it is happening in your buffering part. The TCP receiver advertises the free buffer space in RWND, okay, field in TCP header, in TCP header. So what is the meaning of that? How it is going to do? So it will be some window will be there, receiver window. What is this RWND? Receiver window. So the receiver window will be there and some buffer data will be there. I'll just go back to the previous slide. You can see the TCP socket receiver buffers is connected to your sockets, right? So here all the packet datagrams are storing. So moving towards next one, that much only we are considering now. So that cell is nothing but that is known as your TCP segment payloads. So inside your TCP segment payloads, there are two things. One will be your buffer data, one will be your free buffer space. Okay, it means unbuffered data. So there will be some space which can hold the next packets of data here, and this one will be connected to your socket, TCP socket, and it's moving towards your application process. Whatever the window you can see the free buffer space, that is known as your receive window. So this much of space is known as your receive window. But this much of space, the blue color line, whatever is there, you can see that is your receive buffer. The total from here, this is your buffer data. But receive buffer will be from the top to bottom. So now we will understand what is the meaning of this receive buffer, how it is going to work out. Receive buffer size, set the sockets, okay, which one is having the default bytes of data, that is 4096. It means that the receive buffer has the capacity of storing 4096 bytes of data. That is a default one. We cannot change it. But many operating systems are there which has the auto adjustment of this receive buffer. If some of the operating system wants to change this number of bytes of data, they can increase also, they can decrease also. That is the work of your receive buffer. So now this receive window, what it is going to do? This one will advertise that I have this much of free buffer space. So it will it will just remind to the receiver that you can send the acknowledgement to the sender side to send more packets to accumulate here. Then the next one is sender limits the amount of unacknowledgement data to receive the RWND or receiver window. It means that I told you just now, it will tell to the receiver side that now I have some free buffer space. Now you can intimate to the sender side that it can send more packets of data because I have some extra space where I can allocate all that packets. Guarantees receive buffer will not overflow. And suppose if you have the free buffer space of 2000 bytes and 2096 already buffered data, then you can allocate only 2000 bytes of data. You cannot overflow the data. That is known as your buffered like buffer data and the free buffer space data. All these things will happen inside your TCP receiver side buffering. Now you can see the receive window. Whatever we have discussed here, this window is present over here. Okay. So here what will happen? It will have the flow of control. How many bytes of data it is going to receive. Everything it is going to have a track. So this is present inside your TCP segment format. Now you can see what is the meaning of your TCP connection management. So how it is going to work out? Before exchanging the data, the sender or the receiver has to establish the connections that I have told you in the very beginning of the class. So how they are going to establish the connection? They have to establish the TCP connection by applying the handshaking signal. When the handshaking signal will pass from the sender to the receiver side, that time receiver will understand that yes, some message is going to come from the sender side, so he will be awake to receive the message. Same thing I have told here in this point. So now agree to establish the connections that I told. Next is agree on connection parameters. Whenever the message will pass or packets will pass, to know the or to keep the track of all the packets, we will provide the sequence numbers. We will start some of the sequence number. The sender has to do all this work so that we can keep the track of all the packets, or how many packets has been lost, or how many packets has not been acknowledged, or how many packets has been acknowledged. That's the reason we are using this sequence number. Next one, you can see this is my layers, application layer. So in this layer, sockets are there, here also, this side also. So this is my client side. So how I'm going to connect with my server side? You can see the sequence number is client to server, server to client. Here also client to server, server to client. How I'm going to write this? How I'm going to write these things in a programmatic way. How I will write? Same thing you can find out in your program, in your lab programs also. The same things are there. How you are going to write? You need to write socket, client socket equal to new socket. You are going to create the new socket. You need to pass your host name and your port number. Without passing your host name or the port number, the receiver end cannot connect to the sender, because every time you need to pass the address. What is the next side? How it is going to happen? In this side, socket, connection socket, you are going to connect. This is only to establish the connections. Okay, client wants to give the connection. So how it is going to write the connection? So this line is only about the connection setup. You are going to write here socket, connection socket, all these things are inbuilt. Welcome socket dot accept, then it is going to accept it. Next, how it is? So if all these things we are going to see in a programmatic in a diagrammatic way, how we are going to see? You can see the connection state I have given something. Okay, so that connection state I'm going to use. So if I want to agree the establishment, I need to give the two-way handshake. Why it is known as two-way? Because the sender will send to the receiver, and also receiver will send the acknowledgement to the sender. That's the reason this is bidirectional handshake. So how you are going to do? First you are going to send, let's talk. Okay, you are giving some state active. Let's consider as active state. So now receiver will send okay, then it means that both are ready to discuss. So now similarly, you have client, you have server, you are choosing suppose X, anybody, because there will be n number of servers. Which server you are choosing, you have to specify the server name. So now you are requesting the connection of this server. Now connection establishment. So let's take it as your active stage. Now it is accepted the connections. Okay, in this way it is going to accept. Now what will happen? One question will arise. Will this two-way handshake always work in the network? This is a question. You can get this kind of question in your Viva. Yes, definitely. Variable delays. It means that whenever we will connect with through the variables, that time there is a chance of delay. Okay. And when there will be the chance of delay, whenever the packet will get lost. So that time you need to retransmit the message, and again you have to request for the connections. So you need to be in a network to avoid such kind of things. Okay, then again you have to go for the message reordering, then only you can send the message and you can get the acknowledgement in sequentially, otherwise it will be a problematic. So you need to be in a network. Now the same thing will be there in two-way handshake scenarios. You can see here I have chose the server X. So I'm requesting for the handshaking signal. I have requested for the connection setup. Now it is my state. I have sent it back the acknowledgement to the client side. So it is like accept the connection from the server X. So now it is going to send the data. So the first data it is going to send. It has been accepted the data. This is here x plus 1. You write 10, 11, 12, whatever you want to write. That's just a number. So accept the data. Next, acknowledgement for this sequence number. So acknowledged. Okay. Then connection X completes over here. So no problem in that way. You can see there is no problem. Now next, here one more situation is there where you are going to choose X. You have sent for the request connection. Here this is the state. You have accept the connection. So now what will happen? But you have not sent any kind of data. Just you request for the connection accepted, and you want the client wants to terminate. What will happen? Client terminates. If the client will terminate, then the connection also will get closed. So it means that the server will understand now the like message whatever he wants to pass, it is over. So the server also will forget this X, because maybe in the same time one more Y client wants to send some message, so that time it will just forget the X. So it is not going to save on which kind of clients, or what was the name of the client when it was has been sent the message, or they had some communications. But there is a different method is there where we can keep all the history of the server, like how many clients it has been interacted. It is there. We will see it slowly. Now next what will happen? It can send retransmit the request connection again, or may it can happen due to the network failure. So once the establishment will start, it will be in the mode of active stage, then it will accept the connections. Once accept connections, but what will happen? Already client terminated, right? So what will happen? It is only one sided. The server side wants to connect with the client, but client side they don't want to connect it through your server. So in this case it will have the problem. It is known as your half open connections, where there is no client. The same thing can happen for the server side also. Let's see one more example. Here my client has chose like the server X, where it has been sending for the request connections. The state has been declared. Now my server will send the accept connection. For which server? For my X server. Now the state has been declared as like active stage. Now the data exchange started. I have sent my data with some of the sequence number. When my data has been sent to the sequence number, then the server also accepted the data. But before sending the acknowledgement, the client terminated. So if the client will terminate, then the connection will get over. It will get closed. And also the server will forget for which client it has been connected. So if it will retransmit also for the request connection, again what will happen? If it is asking for the retransmission of the request connection, then definitely it has to go for the X plus 1, the data. The data also it has to retransmit. Then again it will accept. Then what will happen in that case? It cannot send because it will see that the duplicate data accepted. So it cannot send. So this is also a problematic stage for your two-way handshaking scenarios. Now how exactly it is going to happen? Now we will see the three-way handshake because two-way we have seen. Now we will see the three-way handshake. We have two state. One will be client state, one will be server state. In this side, what will happen? Client socket, host name, port number. So here what it is going to do? Server socket, these things are there. That is host name and port numbers. These things are your like inbuilt terms. Okay. So you have to remember all this. What is the work also you need to find out because it is very important. Server socket bind. You are going to use the bind operation. For what it will bind? The space and the server port. Whenever we are going to send anything, we have to send with the port address. That time we are using this bind operation. Next it is what? Server socket listen 1. Listen 1 the sense it is a true value. Means it will accept. Then the connection socket address value will be server socket dot accept. So as it is a true value, it is going to accept. So this is nothing but these things are your client state and server state programs. Whenever you will write any programs, that time you need to specify in this way. Next, what will happen? It is going to use this listen state. Okay, this is a state. What it is going to listen? What was that? My server name and the server port. Where it is going to connect? It is going to connect to my client through the socket. Everything will be through the socket. So here I'm going to connect my server name and the server port. So here what I'm going to choose? This is my client. This is my server. Here I'm going to choose the sequence number and it will send the TCP synchronized message. So let's take, I have sent the first bit as 1, the sequence number as X to my server. What will happen? Here you can see also what I have done. I have sent it, right? So next what will happen? In my server side, it will also choose the sequence number and Y. Okay, it has to change, it has to take. Then it will send this TCP synchronized acknowledgement message and it will acknowledge with that synchronized bit because it has been received. I told you that here it has to go for the bind operation. When it will go for the bind operation, it has to send with the port number. Here it is Y. So it is going to send the data values with the sequence number and acknowledgement bit is 1 and the next acknowledgement number also it has been specified. So what is happening in the server state? This side listen, synchronize sent, this side received. So till here it is correct. Next what is happening? Received the acknowledgement. Okay, which acknowledgement it is received? It received the acknowledgement for this X. And now it can indicate that the server is live and it can accept our data values. Then it will send the acknowledgement. This segment may contain client to server data transformations. So next bit of data it is going to send. So this side also it will indicate that yes, the client is also alive to send any kind of message. So here we can see the state. So it is establishment state. Now it is active mode. So next what will happen? You can see this is just an example where you can see how it is going to be work out in a human way. Okay. You can analyze this. That is like nothing like wrong in this. It is first case, second case, on, belay. So now belay, on. So if you are saying something, someone is doing also, again it is climbing, right? So all these three activities are interconnected. These things, it is just a picture, and you can see that it is, everything is the interconnected. So here one will say means another one has to listen it, then it has to switch on the active mode. So that is the case. So now, once you have done with all your transformation or transmission of the packets, next you have to be, this is the last point where you are going to close the TCP connection. How you are going to close? The client and server each has to close from their side of connections. So the send TCP segment, it is going to send, and again it is going to receive with the acknowledgement, combined with their own like values they are going to do. And simultaneously, both the side, like client side also and in the server side, they have to close the TCP connection. Otherwise they won't understand till what time. So both the acknowledgement they have to send, how they have sent for the accepting the request for the connections. Similar way, to close the request, or to close the TCP connection also, they need to give the request, and they have to, the receiver also will send the acknowledgement that yes, the file transformation section over, and now we can close this TCP connection. So this is the way how you are going to send the like packets from one place to another place, and how you are going to have the TCP flow control.